Hey coding buds. So basically in today's GFG POTD we have a problem print diagonally, and it is a kind of easy enough problem, and it is completely based on two-dimensional array where our problem is given a n cross n square matrix mat, return all the elements of its anti-diagonal from top to bottom. So we know very well about the square matrix. That means a matrix which is having the same number of rows as column, then it is considered to be like a square matrix. All right, but here we have to return all the, or here we have to just print all the elements which are in the form of anti-diagonal. That means from top to bottom. So here, if I have to explain it here, so by the example first, here we have n is equal to 2. That means the size of the matrix, or we can say that n is equal to 2. That means here we have only uh, that means we have two rows. Okay, and here our matrix is given as like 1 2 3 4. So if we are going to check about the diagonal elements for this matrix, so here it is like 1 and 4 will be like only the diagonal matrix. Okay, and if we are going to check about the anti-diagonal diagonal of this matrix, so here we get only 2 and 3. But here in the given problem, here we have to turn, or here we have to just print all the elements in the anti-diagonal form. So that means here we have to first of all print 1, then after that 2 3, then after that 4. Okay, similarly if I'm talking about the second example here, so here n is equal to 3. That means the number of rows for the given matrix will be like 3, or we can simply say that it is a matrix of 3 cross 3. Okay, and here it is a matrix of 2 cross 2. That means having two number of rows and two numbers of columns, right? So here n is equal to 3. That means here it is 3 number of rows and 3 number of columns, and here matrix is like given as 1 2 3 4 5 6 7 8 9. So if I have to ask from you like what is the diagonal for the given matrix, so we know very well diagonal matrix are those where the size, or here where we can say that the condition where I is like equal to j. We all know about matrix. Okay, matrix basically represents the rows and columns. Like rows is like represented by using I, and the column is like represented by using j. So if we can say that if I is equal to j, that means if both are having the same values, then it is considered to be like diagonal matrix. Like for example here 0 0, then 1 1, then 2 2. So here we can say if I is like equal to j, that means it is considered to be like diagonal matrix. Okay, and if I have to say, or if I have to ask something from you like what is anti-diagonal matrix, so if we have to just uh, make it anti-diagonally, so here we got only 3 5 7. Okay, so this thing is actually we can get it by we can say that if I plus j is equal to, we can say that n minus 1, that means the size of matrix minus 1, then we get the diagonal anti-diagonal matrix, but only this number we actually getting. But here in the given form, here to just simply return all the element, okay, in the same way. That means in the form of anti-diagonal way. So for that, what we can do here our expected time complexity is like order of n square, and expected auxiliary space is like order of n square. And this question is like asked in Amazon, and this is completely based on our matrix data structure and miscellaneous. Okay, so let's try to solve this problem. First of all, I'm going to just like to solve this problem by using brute force approach. So first of all, what I have to do, I have to create the vector for, or let's say answer vector, to store my final value, okay, which is in the form of one dimensional or 1D vector. Okay, so here we have to create a vector of integer type. Let's say here I'm declaring it as an answer variable that basically stores all the diagonal or anti-diagonal elements. Okay, here in the answer here to just simply store all the anti-diagonal elements, okay, sequentially. Okay, so here what I have to do here, first of all I have to also define the size of matrix. So here int n is equal to matrix dot size. Here matrix is like represented as mat, so mat dot size. Okay, then after that here we have to just simply traverse. Okay, so I'm going to explain to you very easy way. So for int I is equal to 0, I is like less than n, and then I plus plus. Okay, or int j is equal to 0 and j is like less than n, and then j plus plus. Okay, and then here we can say that if we are giving the condition, if I'm giving as I is equal to j, that means here it is the, we consider conditional statement for checking diagonal elements. Okay, diagonal elements only, which is really very easy at all. If we know whatever, we can easily to store it. Okay, so here answer dot pushback, and then we can simply store our matrix of I and j. Okay, if we actually doing these things, then here by solving this problem, by this way we are actually getting only diagonal elements. So if we are like return answer, we can check it here that in while compiling and run, I am actually getting only the diagonal elements. Okay, so here I've done something mistake here. Okay, so here I have to give for int I. Okay, let's try to compile and run again. So yeah, here we can say that for the given from 1 2 3 4, here I'm actually getting only 1 and 4, which is in the diagonal, really diagonal elements. Okay, but here we have to return the anti-diagonal way. So if I have to explain it here, so here I can say that if I plus j is equal to if we say that if we like add I and j, okay, and which is maybe like equal to, we can say that the matrix of size minus, if we are like doing this way, then let's say try to compile and run. So what actually I'm getting here, so for this n minus 1. Okay, so yeah, here if we are going to follow this way, like I plus j is equal to n minus 1, so in that case, if our matrix is like in the form of 1 2 3 4, so if we are going to check it, the anti-diagonal elements, so here we are actually getting only 2 and 3. So as you can see in my output is also like 2 and 3. So this is the way, but here we have to print all the elements in the same way, that means in the anti-diagonal way. So in that case what we will do, so our brute force approach will be like, here we have to do one more, here to get one more for loop. Okay, so our time complexity will be like order of n cube. So here we can set for int sum. Here I'm going to declare it as a sum, so sum is equal to 0, and then here we have to define as sum is like whenever sum is like less than or equal to 2, which is multiplied with the size of matrix. That means here we have defined it as n, so minus 2, and then sum plus plus. If we are actually following this code, and then after that here to give the condition. Alright, so here in that if condition, here if we have to do anti-diagonal element, okay, anti-diagonal elements only. So here we have to give the condition if I plus j is like equal to, if it is like equal to sum, then it will return, it will print all the elements in the anti-diagonal, in the form of anti-diagonal way. So let's try to compile and run. So yeah, as we can see, for the given matrix 1 2 3 4, here first of all we get 1, then after that 2 3, then 4, and here output will be like 1 2 3 4, and structure out is also like equal. So let's try to submit it. So yeah, it's submitted. So yeah, that's all for today. Thanks for watching.